Hello everybody, my name is Florian. Today I'm going to show you how to create this effect. We're going to rip apart any geometry using Cinema 4D's cloth dynamics, and with the help of a little bit of XPresso we can define where exactly our geometry should be affected by cloth and should rip apart and should break. And so we're not bound to actually paint vertex maps or anything. We're just using a MoGraph Effector to help us achieve this effect. So you can see the teapot is only tearing apart on the top part, and the legs keep their original animation, and the legs keep on walking as the top part is being torn apart and flying away. So let's go straight into Cinema and see this setup within the viewport. It's running a bit slow. That's because of the XPresso that's running in the background. So for the sake of this tutorial, I'm going to show you what I did here on a simpler geometry. But you can see as the teapot is running through this effector here, which is just a plane effector, as it gets into the fall off radius, the corresponding bits of the geometry are being ripped apart. So for example, I increase the size, oops, not this one. If I increase the size of my plane effector and let the teapot walk through it, it will look as if he would kind of go through a force field and dissolve there. So that can be quite nice and interesting as well. We're going to start with a new file, and let's use a torus for this one. We're going to make it editable and put on some dynamics on this guy, some animation on this guy. So set a keyframe here, then let's maybe go to frame 20, put him down here, rotate it, set another keyframe, and at frame 40 should be rotated again a little bit, and at frame 60 it should come up again. So this is what our animation looks like. It's a very nice animation. You could probably sell it. So if we use a cloth tag on this torus now, and we're going to play it, you'll see our animation is lost. The bounding box is still doing something, so you can see internally it's somehow calculating the animation, but the cloth tag is overriding whatever our actual animation looked like. So we gotta find a way to bring our animation back onto the object. And how we're doing this is we're gonna duplicate the torus, call this one proxy torus, and get rid of the cloth tag on this one, and we can then on our original master torus we can delete all of our keyframes because we don't need them anymore. And so the proxy torus has no cloth tag on it, so he is moving correctly. What we're going to do is we're going to put a cloth belt tag onto our actual torus, and we will select all the points and drag the proxy torus into the belt on field here and press set, which will, if I turn off this guy, which will, here we go, all our points become yellow. So all our points are now connected to our proxy torus. This works in the way that it's searching for the nearest point and is connecting it to it. If you have geometry of your own, like I figured that out earlier when I used the teapot for it, you should watch out for intersecting or overlapping vertices. So if you have multiple vertices on exactly the same position, be sure to optimize your mesh, otherwise the cloth belt tag will kind of do funky stuff and will not work properly. But for this mesh we're good. So if I play this now, you will see our animation is working again now. The proxy torus is invisible, so this one is the actual torus that has no keyframes on it. It's getting its animation inherited by the proxy torus via the belt tag. This is really nice. And our cloth simulation, our cloth tag is still, let me close this for a little more space here. Our cloth tag is still on, it's still working, still enabled. The cloth engine is still working in the background, but it's not doing anything because everything's being overwritten by the cloth belt now. So what we're going to do is we're going to paint a vertex map onto our torus here. Let's paint it like this, and invert it and set our vertex weight to 100%. And we won't name this for now. Drag this into our influence field here, and you will see that everything that's being influenced by the belt tag has the animation, and everything that's not being influenced anymore uses the cloth dynamics to move around and wiggle and jiggle and whatever. So this is nice. Now we have to find a way to dynamically animate our vertex map because we want our cloth animation to be more dynamic and more easy to control. How are we going to do this? I will make a new null and put an XPresso tag on it and maybe call it XPresso and get our editor here and move it down there. Close this guy and give us a bit more real estate here. Very nice. Okay, so what we want to do, we want to generate a vertex map based on the fall off of an effector. There is some stuff online that's doing exactly that. It's also an XPresso script actually. I will just quickly going to recreate this one. So we will use a plane effector, and on our plane effector we will turn on spherical fall off, and this should be our influence field for our vertex map. So we will need our plane effector here. Let's make this more dynamic. Pop in some user data. We will need a geometry. Make this a link. Duplicate this one. Call this effector. This is also a link, and then we will need our original vertex map. All right. So into those three fields, we will going to put our torus here, our effector here, and our vertex map here. This is just so we can easily exchange our geometry, or if we're going to decide we don't want to go for a torus, or we don't want to go for this effector or whatever, so we don't have to go into the XPresso. We can change everything within our user data field of this XPresso null. So our plane effector is here. We will also need, actually we won't need the plane effector now. We can use this XPresso null and output our effector here. Then let's duplicate it. We will output our geometry here. Let's get rid of this one and duplicate it again and get rid of this and put in our original vertex map here. So the way we're going to do this is we're going to use the sample node to get access to the fall off information of our effector, and then we're going to write the value of our sample node onto our vertex map. Vertex maps have values between 0 and 1 on every vertex point. Our sample node has a value between 0 and 1 depending of if our a certain point is within or without the fall off range. So we can just map this on the other 1 to 1. So our sample node will need our effector in the effector tab, and we're gonna need our to iterate through a couple of points. So let's do this quickly. Let's move this to the side for a second. We're gonna drag in our geometry into this object input here. What the point node does, it can give us access to all of the separate points of this torus object here. So all of the points here, they all have an index number, and this is what we can access here and get their position and the point count and stuff. So we will need to iterate through the amount of points that the geometry has. So we're gonna need an iteration node, and we're gonna iterate from 0 to the number of points we have. So if we have a point count of say 100, we will have to iterate from 0 to 99. So we need a math node and subtract 1 from our point count to get the actual iteration end. So that's what we're doing here. Let's put this here, here, and here. And let's move this here, and we need a second point node. The thing is, we now want to iterate. We use this iteration here to input here, and this XPresso doesn't allow you to do this. This is why this line here becomes gray, so we need to duplicate our point node and drag in our object again here, and the iteration to the point index here. So now we're just iterating through all our points in our geometry, and we're outputting our point position, and we want to input this to the global matrix of this sample node. So this outputs a position, and this input is a global matrix. So we need to convert our position to a matrix that has 12 values instead of 3. So there is a node for that as well. It's called vector to matrix. We're just gonna input our point position here into the offset field and get our matrix here and put it into the input field of our sample node there. We don't have to care about those values here because we're just gonna care about the actual point position of the matrix. So it doesn't matter what you input into V1, V2, and V3. So what this node now is outputting is a strength value, which is a value between 0 and 1 depending on the fall-off value from our effector. So we will input this into our vertex map. We need the vertex map node here and drag in our vertex map into the tag field, and we need an index because we want to go through all the vertex points of our vertex map. So this index is the guy from this iteration here. Oops. So this is this guy. Maybe we can move this here. So on this vertex map, we also want to input the value, and this value is exactly the value of our strength. So if we're going to have a look at this vertex map now, you can see it's exactly the the fall off of our effector is more or less or is exactly defining the values of our vertex map. So as you've seen earlier, if the vertex map is at 100% or the vertex weight is 100%, stuff is being affected by our belt tag, and if it's at 0%, which is red, it's being affected by cloth. So actually we want it when the torus comes down, it's being affected by the cloth dynamics. So we want this to be exactly the opposite of what it is now. We can do that by just using a range mapper between those two nodes to invert our map here. So let's grab a range mapper and put this input field here, and this goes to the value. And on our range mapper, we just set from 0, we go from 0 to 1, and we want to output 1 to 0, which is just inverting our input here. Let's call this guy for a second original, because we're going to make another one shortly, original. So now if we play the animation, I don't know if you can see this. I think you can. When the torus gets into the influence of the effector, the cloth is taking over, and as soon as it gets out of the effector again, the cloth is not affecting our object anymore, so it pops back to place as soon as it leaves the vertex map. This is not what we want, actually. I mean, if this is what you want, then go for it, but for our example, it's not what we want. The reason why it's not what what we want is because we want to tear our cloth apart. So to tear stuff apart, we just have to turn on tear here, and you will see we're gonna get strange artifacts, strange motion here. So stuff is tearing very strangely. So to actually use tear, you have to put your geometry into a cloth surface. So that's this. And now you see, as soon as it's in the cloth surface, our actual cloth is has disappeared. So let's just set our subdivisions to 0 on that one and play it again. So you see our cloth is tearing and is going wherever it wants to go, but it still does look kind of not right. As you see, it's behaving not like cloth should behave. So our polygons are kind of disappearing, and it's just not. There's still something wrong in here. So the reason for this happening is when if I turn off the cloth surface for a second, the reason for this happening is as soon as this becomes red and our cloth belt is not affecting it anymore, the cloth dynamics is taking over. As soon as a polygon has the information that it actually has teared, so it's probably an internally stored value for it being teared, it will go to a random position in space. You see this? This is somewhere, and it's just not really correlating well with the fact that our belt dynamics wants to take over our cloth dynamics again when the vertex map turns yellow again. So what we want to create now is a second vertex map that once it turned red never turns yellow again. So let's call this lazy vertex map. So how are we going to achieve this? Let's go to our XPresso again, and we want to, actually we can reuse most of this stuff because we want to iterate through all the points again. So we can use this bit here, just duplicate it, and like this. And we need this vertex map. Actually, we will make another user data here and duplicate this one and call it lazy vertex map and drag in our lazy one, and we'll get our XPresso out and get our lazy vertex map, duplicate it, and get our original vertex map. And we want to compare those two vertex maps. I need a vertex map node here, drag this one in here, and oops, duplicate it and drag this one in here. And we need to get an index, so we take this from our iteration here. All right, and now we have a value from the lazy vertex map and a value from the original vertex map, and we want to compare those guys. So if a point on the lazy vertex map is, let's say, smaller than a point on the original vertex map, we will then, it's not a switch node, we will, it is a condition node, and then I'll put this into the switch input here, and depending on what was bigger and what was smaller. So if the lazy vertex map value is smaller, then this outputs 1, which will in turn make this output the bottom input. So this needs to go here, and this needs to go here. Sorry, it's a bit messy here, but we won't have to worry for this now about this now. So this output then goes into our our original vertex map. Oops. Like this. So we'll input this into our value field here. And we also need our index from this guy. So if we make the viewport bigger again, and this is our original vertex map, this is our lazy vertex map. If you watch it, and let's deactivate the tearing for a second. It's not there yet. This is smaller. This one compare it smaller. We're gonna take this. Trade into our original. Oh, that was wrong. This should be our lazy vertex map. Right. So if I go back again, you see, once we've painted on it, it will stay red and it will not go back to yellow again, even if we move the torus outside of our fall-off range. So this is alright, this is working, but the problem is now at frame 0 we have this state of our vertex map, so we need to kind of reset the vertex map on frame 0. So we're going to do this by using a time node, and we need a frame, and then we also need a compare node here. We're going to compare the frame. If the frame is 0, we want to reset our state. So we need another condition node here. So if the frame is 0, this node outputs 1, which will then let this input through here. So on frame 0, we want to have our vertex map value 1, and otherwise it will get this value and output it again onto our lazy vertex map. So if we go to frame 0, oh sorry, this should be 0 and this should be 1. So if our frame is equals 0, then we will output the value 1 onto all of our points on our vertex map. So if we play this now, you can see as the animation plays, we're going to paint the vertex map, and on frame 0 is going to reset to everything is 100%, everything is yellow or white or whatever this color is. So let's use our lazy map now for our influence field here, and turn on the tearing again, and turn on our cloth surface again, and play the animation. And you will see now, once it entered the plane effector's influence field, our tearing will occur and it will look nice, and there will not be any miscalculations, and yeah, that's looking really nice. This is exactly what I did on the teapot example, and this one, and this is how you can do this, how you can control your vertex maps with XPresso, and you can make this kind of lazy vertex map thing and use this to drive your belt tag. And yeah, I hope you learned a thing or two, and you enjoyed it, and let me know in the comments if you have any questions, and talk to you soon, and have a nice day.